Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight for his last stream is one of our students who I will let say hi.
Hi,
Oh,
I'm
bye.
Eli. Yeah, I'm Eli. I was a physics and astronomy student at UMD.
And with the Planetarium for 4 years. A very familiar face to anyone who has been to our streams this past. Oh, it's been like 2 years now, hasn't it?
Yeah, over.
All right, so since this is Eli's last stream, we decided it would be a great way to send him off by doing one of the shows that he created. And so he's going to be doing the Star Wars show, which started off as kind of a revamping of a show that the Planetarium previously had, and has turned into a great project that Eli worked on. So I'm going to turn things over to him. As always, throughout the show, if you have any questions, you can leave them down in the comments. I will be keeping an eye on those and we'll let Eli know when questions come up. If we don't get to them right away, don't worry. We will have time at the end to answer questions as well. So, with that, Eli, it is all yours.
Alrighty, hold on. Let me make sure I get the right window up. How does that look? Okay, great. Alrighty, so Star Wars Fact or Fiction is just kind of a look at some of the things from Star Wars that jive with reality and science and some of the things that don't so much. And the first one we'll talk about is binary systems. So in Star Wars, we have Tatooine, kind of the main hub for a lot of the movies and shows. And Tatooine is a planet that orbits a binary star, which is two stars that orbit each other. This is what's seen in that awesome double sunset scene that you're seeing on the screen. And these binary stars actually exist everywhere in our universe, as far as we can tell. And we think that up to 85% of star systems are at least binary, while some can have even 3 or 4 stars. The next one is habitable zones. So the habitable zone around stars is the range of orbits where an Earth-like planet could support necessary conditions for life, such as liquid water and reasonable temperatures. And this assumes that all extraterrestrial life would share the requirements of life on Earth, which we don't know to be the truth. But given that we haven't found any life that doesn't share the criteria of Earth life, it's probably a pretty good place to start. So the hotter a star gets, the further away the range is from the star. So we kind of see this vaguely in Star Wars, as different worlds exhibit qualities we would see in planets in different locations in the habitable zones, like Tatooine, mostly a desert, really, really hot. We would assume that it's a little bit closer to the star, whereas Endor kind of in the sweet spot, just like Earth, and then Hoth, obviously much colder. And a little further out from the star. Now, this isn't really a fact or fiction question, but I think it's pretty interesting. So Saturn's innermost moon, which is called Mimas, looks like the Death Star from a distance. Discovered by 1789 by astronomer William Herschel, it hosts a crater that resembles the Death Star superlaser. You can see that right there, like almost kind of alarmingly so. That crater was discovered in 1980, and the original Star Wars movie came out in 1977. So it was actually the Death Star was made in a movie first, and then astronomers discovered a crater that makes this moon look exactly like it. So kind of eerie. The other interesting thing is because the crater obviously gets much closer to the planet's core and gets warmer, it glows in the infrared, which is much like a super laser would, I would imagine. Another interesting one is blaster weapons. So in Star Wars, they're commonly mistaken as lasers, but blasters fire, and this is a quote, bolts of intense plasma energy converted from energy-rich gas. While this may sound like the work of science fiction, it's actually entirely possible and has already been done. Plasma is kind of, they call it quote unquote, the fourth state of matter, in which charged particles like electrons detach from atoms and flow freely. The bolts we see here would be plasmoids, globs of plasma held in a distinct shape by electric or magnetic fields. These fields can be generated as the bolt travels by shaping the bolt into a spheromac, which is a configuration of plasma that would generate a magnetic field as it moved. They kind of look like a donut a little bit. The spheromacs only hold their shape for tens to hundreds of microseconds, but that's actually plenty of time for a blaster bolt to travel the distance it needs to, because those particles are moving extremely fast. The plasma in these bolts burns at thousands of times the temperature of the surface of the sun and could certainly do damage to whatever they hit. So while on the larger scale, blaster weapons are probably a long ways out, the concepts underneath them are actually at work already today. Another one I like to talk about is kind of flight dynamics in Star Wars. This is something that they get pretty wrong. So in Star Wars, we see very few differences between flight on a planet and flight in space, when in reality, they would be completely different experiences. So on a planet with an atmosphere, your craft is subject to many forces imparted by the air you're flying through. In order to turn, an aircraft must execute what's called a banked turn, where the plane slightly tilts to one side. You can kind of see it here. So you've always got the force of gravity pulling your plane down, and you've got the lift force pulling your plane or pushing your plane up, which is generated by the wind streaming past the wings. But if you were to tip your plane to the side, you can see that the lift force is then pointing you in a different up and to the side, and the combination of that would cause your plane to turn in like a circular radius. So that's how planes execute turns. It's not like the boosters start firing in a different direction. The plane just tilts and it starts to push to the side. In space, however, without the presence of an atmosphere or a planet supplying lift and gravity, you have to create all of your own forces to move your ship. So for example, if we wanted our Millennium Falcon here to move in the direction of the green arrow, we'd need to combine both forces represented by the red arrows. So you need to have a booster pushing this way and that way. We're firing these ways, and then it would push in these two directions, which would combine to form a net force in that direction. In order to have full range of movement, we have to have rockets at the rear, front, bottom, top, left, and right of the ship to provide forces that can be combined to move the ship anywhere it wants. And once you get into turning the ship, you're in a whole different ballgame that we're not going to get into here, but it gets ever more complex from that. The other thing that always grabbed my attention was that all the ships are always oriented in the same direction, always. And that doesn't really break any laws of physics or anything like that. But it's interesting to me that when in space, where there's no up or down or proper orientation, and all of the ships are taking off from different planets and things like that, that they're all oriented in the same way. It would seem a lot more likely that they would all be oriented in different ways. But that's not what we see. One more little tidbit, the asteroid fields in Star Wars are a lot different from the asteroid belt in our solar system. In Star Wars, there are these kind of super dense, hazardous, almost impossible to navigate regions of space, whereas in the solar system, our asteroid field is just a step below empty space. A probe flying through our asteroid belt has a less than 1 in a billion chance have gone through that region without even seeing a single asteroid. So you wouldn't find a situation like this. This would probably be more resemblance. Another problem with Star Wars, specifically space flights, is the fact that we see these seismic waves and sound propagate through space. This is impossible because in space there's no medium for seismic waves or sound to travel through. On Earth here we have air, which is really good at carrying sound around. We have the ground, which is really good at transferring seismic waves. But in space, there's no air, there's no ground if you're in space. So you wouldn't be able to, first of all, hear anything, or have like earthquakes or something like that, because you can see here as the seismic charge detonates, it like blows up this stuff around it, but it shouldn't do that because there's no stuff for the wave to travel through. It would have to be like particles flying out or something, but I don't think that's what they were going for there. Traveling through space would also be no easy task. So The fastest speed reached by a man-made object as of now was 153,454 miles per hour, which was done by the Parker Solar Probe in 2018. Even traveling at this speed, it would take 40 days to get from Earth to Mars, which are the two planets that we're kind of focused on going to Mars. So that's kind of our closest objective. If we wanted to go from one planet to another at the other side of the galaxy, like the journey from Tatooine to Ilum, if you don't know, Ilum is a planet where Jedi younglings find their kyber crystal to power their lightsaber. That journey would take 462 billion years, which is about 33 times the age of the universe. So traveling through space is a little more logistically unsound than it's portrayed to be in Star Wars. But they came up with a workaround. Hyperspace is kind of a shortcut between points A and B in Star Wars. And to get to hyperspace, ships must reach the speed of light. And we all know getting to the speed of light is impossible. As an object's speed increases, it takes more and more energy to accelerate it to greater speeds. And once you get to speeds close to that of the speed of light, it asymptotically reaches infinity. So you would not be able to generate enough energy to propel something to the speed of light. So getting to hyperspace would be impossible. Another problem with that is that amount of acceleration would kill you, because it would be such a jolt that actually the actual term is called jolt. As your acceleration increased and increased, it would just kill you. That's why in Star Trek they have inertial dampeners, so that jumping to those speeds don't kill people inside the ships. Star Wars didn't say anything about that. So,
But I think, don't they spoof on that in Spaceballs?
I have never seen Spaceballs.
I've seen like a few clips here and there, and I feel like they spoof on that idea.
They probably do. I don't know, but like I said, I've never seen it, so I should probably watch it. One thing Star Wars did get right, despite widespread belief that it was a misinformed error, was the famous Han Solo line. The Millennium Falcon made the Kessel Run in 12 parsecs. At first, it sounds like Han said it made this drive in this distance, which would be like saying I drove from Minneapolis to Los Angeles in 20 miles. It just doesn't make any sense. A parsec is a unit of distance equal to just over 3 light years. But so we know obviously that sounds wrong. But what Han was actually saying is that since the Millennium Falcon is so fast, he was able to take a shortcut through a dangerous region of space to make the trip shorter. So this blue line that you're seeing here is called the Kessel Run. And it is a traditional shipping route that goes from planet Kessel to the planet Obadiah. So they would have to bob and weave throughout these asteroid fields and debris fields and stuff like that. But what Han Solo was saying is that he was able to cut that journey short by just jumping right through the debris field, and specifically right through a region called the Maw that has a bunch of black holes and stuff. So it's just more of a testament to how fast and how powerful the Millennium Falcon is, and it actually does jive with reality. Now the last one, we arrive at the lightsaber. Well, lightsabers are really cool, and I think many more people than myself wish that they were real. There are just a lot of logistical problems. So lightsabers could be constructed in the same way that the blaster bolts are, with the plasma contained in some self-generated magnetic field or something like that. Or it could be like a laser in the hilt or something like that. But the energy to consistently heat the plasma or power the laser would be way too much to be able to hold into your hand. Also, there would be no way to stop the plasma at the end of the blade, which is not very convenient. So, you just have an infinitely long blade, which doesn't work very well. Same thing would happen with light. You'd have to stop it with some type of mirror, but that not only ruins your ability to stab with the saber, but then also you have just as much energetic light going back right at your hand. So that doesn't really work either. We also run into the problem of cooling the hilt, which would take more energy and space than is available. And not to mention the battle constraints would be kind of devastating. So since the plasma is extremely light and light itself is massless, the weight balance would all be in the hilt, unlike the sword where it's somewhere in the middle. And it would feel really awkward to swing the blade. And also due to the fact that plasma and light are not solid, you wouldn't get any of the cool noises that crash into each other. They just go right through each other. So kind of anticlimactic, but we don't want to end on a dream crushing note. So the popular YouTube channel Hacksmith has created many iterations of a real working lightsaber. And the way they do it is they take a tungsten blade, which has an extremely high melting point, and they heat it up to just before its melting point. So you've got this tungsten blade that's super hot. It can cut through metal. And there have been many iterations. I would encourage you to go check out the videos because they're really cool. I should issue a warning. There are some cuss words and things like that in the channel. So if you have little children, maybe censor it however you see fit. But I would encourage you to go check it out because it is really cool and I really want to build one, although I'd probably mess it up. So yeah, that is actually all I have. I kind of flew through it this time, but I'm gonna stop
It's almost
sharing.
like you've done this a few times.
Yeah.
Oh, so no questions. There is an insistence that you must see Spaceballs.
Okay, I will do my best.
Oh, no, and for those in the Duluth area or interested in visiting, Eli has been working on a version of the show for the planetarium. So it will be a full-fledged show using, full digital fun stuff on the dome. So yeah, he will live on with his
I
Star Wars
will.
show.
I'll have a brick in the back too.
Yes. Yeah, you gotta work on that.
Mm-hmm.
Okay. Well, we'll do another call for any questions. Um, see if there are any of them. Quinn just wants to say hi. Uh, otherwise, I don't know. I don't want it to end. I
Yeah,
feel like we should have like, I don't know, something more.
yeah. Weird. Been 2 years doing this.
Okay, so we got a question. I'm not quite sure what this is. How would you justify the sounds of the passing spacecraft, like during the battles? Oh, like
Oh,
during the battles.
uh, they would. There would be no
Yeah.
sound. Um, there's no medium for them to travel through. You would have to be in actual physical contact for that to happen. And if you're in physical contact, you'd have bigger problems than hearing something.
Yeah. No sound, which I mean definitely makes scenes maybe less exciting, which I know is why they include sound in all of
Yeah.
those. I always like it when you see like a big explosion in space and a sci-fi and it's just like dead silent.
Yeah.
I actually find that a little bit more terrifying.
Yeah. And I think something I really like about certain movies, and this is something I've talked about with my friends, is like I feel like space movies are a really good opportunity for a composer to like really shine because it's like in scenes where like an explosion happens in space or like you're watching a spaceship or something like that. There's no actual sound from the movie itself, so I feel like it's a really good opportunity for composers to kind of strut their stuff, which I feel like uh what's the movie called? Interstellar, Hans Zimmer. I feel like it was such a great opportunity and he just like nailed it right on the head.
I still haven't seen it.
Oh, it's really good.
I know, it's on the list. I haven't gotten to it. I
Yeah.
know I need to though. Don't you have a book that's like the physics of Interstellar or something? Was that you or Josh who had
That is
that?
not me.
Okay, that must have been Josh.
At least I don't think I do. No, I don't think so.
Yeah,
Both
must have been
Paris and
Josh.
Minnesota.
All
It
right.
was weird. I was at Savers last week, and I was looking at books, and there was Birds of Iowa, and I thought about it. I was like, that's a really weird coincidence. Yeah, I don't know.
Oh, no. All right. So I'm seeing some more talk in the comments about maybe how you could get some sound. I don't know if you're interested in reading through that. Um, but I'm not seeing any more questions directly. So I think we will begin to wrap things up. If you want to, I don't know, you can read through that real quick and I'll go over our schedule for the week.
Yeah, sure.
Let me find, there it is. For the rest of the week, Friday and Saturday, we have our in-person shows at the Planetarium. Friday is going to be Journey Through the Solar System, and Saturday is the last showing of Earth, Moon, Sun, and Mars 1001. After this week, we will be switching to a new set of shows for Saturdays. And in fact, for Mars 1001, that will be the last time that we will be showing it publicly at all, because again we have a short-term license, so that's as long as we are legally allowed to show it. So if you want to see those, get your tickets. I think we have a few sold, but right now it's mostly open, so if you want to come, I would advise going ahead and getting your tickets now. You can find a link to do that in the video description. And then next Wednesday's show will be our What's Up June, because it'll be somehow the beginning of June. Don't know how that happened. I feel like this month like extra flew by because of field trips.
Yeah.
It's for anyone who isn't aware, any sort of outreach or informal education always has what we call field trip season. April and May are field trip season for the planetarium, and we have been extremely busy the past several weeks with field trips. I think, what's our current count? We're at like almost 700 students
Yeah.
came through the
Somewhere around there.
planetarium throughout the month of May, and I think we still have a couple more field trips left in May.
Got. I think there's one on Friday.
And I think there's one next Tuesday as well, which is
Okay.
technically still May.
Right.
So we have been incredibly busy. And I definitely feel like that has made this month fly by.
Yeah.
Um, but yeah, all right. Well, there are some thank yous and we'll miss yous, Eli, in the comments.
Miss you guys too.
So for anyone just joining us, this is Eli's last live stream as he has graduated, and will be moving out this weekend.
Yep.
So if you're in Duluth, you can
Sunday.
still come see him Friday or Saturday.
Yep.
He will be at the planetarium, but this is his last live stream. I've done good. I've held it together.
Yeah, I'm not usually a very like emotional or like touchy-feely person. But I don't know, in the last couple of days, like it's been kind of like, I don't know, I'm starting to pack up my room here, and it's just weird because it's like this has been, my house for 4 years, and it seems, you say 4 years and it seems like it's not a huge part of time, but I mean, I'm 22, so 4 years is,
Yeah.
less than or more than a sixth of my life. So it's like just to be packing up and moving out, and leaving the planetarium, and yeah, I don't know. Duluth was very good to me. The planetarium was awesome. I made very good friends. I met a wonderful girlfriend. Yeah, I don't know. It's kind of sad, but I've been trying to keep my zen, and I've been doing all right. So
I can guarantee you this will not be the case come Saturday.
yeah, yeah, it's gonna be tough because that will be the last time we see each other too.
Yeah.
Yeah.
And I figure I was gonna let you do the Star Show Saturday night.
Yeah.
For your last. Okay, I don't want to talk about it anymore. I don't want to think about it. Okay,
So
let's just end stream on happy notes. Um, thank you everyone for joining us. Thank you for your support. Um, and yeah, tell Eli how awesome he is in the comments. I'm hoping to push him into the planetarium in Iowa, so maybe we'll get to see more of him. We'll see what they do.
yeah,
Um,
I'm kind of at their mercy now, so we will see.
and of course, if I can ever drag him back, he will do more stuff with us. If ever he's
Absolutely.
back in Duluth.
I will be. I will for sure be.
All
Too many
right.
good state parks up here to not come back.
It's true. It's very true. Okay. Thank you for joining us. We hope you have a wonderful rest of your evening. I know it's been a rainy, stormy day here in Duluth.
Yeah.
But enjoy the rest of your evening, and we will see you again, or I will see you again next time. So, bye everyone.